So the workshop's going to be formatted kind of like what you see on the screen. If everybody can see the screen, we're going to talk a little bit about what is Konstru. We're going to present it and say like why we made it and kind of what's its use and applications and other purposes. Then we're going to go a little bit into Konstru tools and workflow techniques you can apply to projects and other projects and other conditions you might find yourself when using Konstru. Then we'll go through some very simple examples, primarily focused on Rhino, Grasshopper, Revit, and eTabs, showing how you can use Konstru to sort of be a bridge between all these, and as well as like how to create a file and whatnot, and edit models. And lastly, if there's questions, we're going to have a little portion just set up for text questions or voice questions if you guys would like to speak up and participate just towards the end. This is like a more in-depth outline of what I was saying. We're not going to go too deep into this because we're going to pretty much hit it as we go through the presentation. But to start off, general knowledge. What is Konstru? All right, it's basically a platform between platforms. Think of it as a bridge. You take model A, you turn it into model B. For example, let's say you have a model in Revit and you want to transfer it over, or in other words, translate it into Excel or translate it into SAP, Tekla, RAM, or even Rhino. It's literally made for the idea of being able to transfer models left and right. Now, why do we have this bridge and why did we make it? Primarily, it's because we were focused on the idea of transferring BIM models. Now, as everyone knows, building information modeling and BIM models themselves carry a lot of data. They carry an enormous amount of metadata that can be anything from like beam profiles, sections, to offsets, to pullbacks, to even forces, and it kind of, the list really goes on, especially if you go by application. Like if you go into the realm of Revit, any particular beam can have endless parameters attached to it, versus if you go into the realm of CSI, such as SAP and eTabs and other analysis platforms, well, we all know that after analysis and all this stuff, any particular member can have an endless amount of conditions that you definitely want to carry on as you carry the project, whether it's through SD, DD, or even CD phases. Now, the reason why we develop Konstru is just precisely because of that. We want to be able to translate model from one platform to the other and not lose all that metadata, not lose all that very important information that becomes crucial for making decisions in pretty much any phase of the project. Now, the way Konstru works is there's a very simple sort of hierarchy that's set up when you're translating models from A to B. For example, in the diagram you see on the screen, you have a Konstru organization. In other words, we could refer to as a Konstru model. Within that model, you have a series of smaller subsets such as columns, beams, levels, and floors. This, of course, varies a little bit per application, but in a general sense, like if you break a building down into these, we have these series of subsets. Now, within each subset, take for example a column, a level, or beams, as we have diagrammed here, there's a series of metadata that's attached to it, which is often, or not often, which is represented in the tabular form, very similar to an Excel sheet. And that goes across any sort of translation when you're using Konstru. And that's how all the data gets stored when using Konstru, regardless of which platform you're going in or out of. Now, here's a little animation that's going to kind of explain the idea of what happens when you upload and download to Konstru. Take, for example, a Revit model. Konstru is basically a database for all your 3D models, breaking everything down into just text, right, into what it is. First, it'll read your local model and extract all the basic information you need to be able to translate it, such as displayed here. On the very first part, it's going to read the local model and it's going to compare that to an existing database. If there's no model, it'll make a version 1. If there's an existing model, it'll ask you to update it. In this case, we're saying you just uploaded a brand new model to an empty Konstru container. Once you've done that, let's say you go to your target platform, you can then read that uploaded model and download it, but then it's going to check if your model is empty or if it's existing. It does a comparison between the cloud and the local file and the platform. If there's nothing in the local file, it'll just download the whole thing in there and eventually create a brand new model. As you can see here, that's kind of like in a nutshell how you can translate from Revit to SAP in this case. And then in another way to look at it, it's basically what happens at the back end. Like in the front end, we're going to see all these geometries, all these things, all these profiles and data. But in the back end, it's really just an Excel sheet with a numerous amount of information that's tagged to every single BIM element. Now, regarding the idea of translations, there's a series of many different ways we could use Konstru to go from point A to point B. Primarily, we have what could be referred to as a one-way trip, whereas we take a model from platform A, such as Revit, and we translate it into platform B, such as ETABS. It's a very simple sort of one-way maneuver, and it requires uploading to Konstru and then downloading back onto ETABS. We have another possible workflow that you could get through, which is basically a round trip workflow, where you take model A, then you convert it into model B, and then you send that data back to model B. Now, we're going to go into this a little bit more in depth in the following slides, but essentially take a Revit model, make a blank version, like a brand new model in Konstru. You can download that into SAP, make some changes, run some analysis, then run it, then upload it back into Konstru, and then send it back into Revit. Like I said, there will be a series of more in-depth diagrams and videos and explanations to show you how this works. Now, for model merging, it's kind of the idea of like, what if you have two separate models from two separate applications that have been being developed, but they're very similar, and eventually they need to transfer. This happens a lot when you're dealing with sort of design models, such as something that falls more in the Revit realm, and then analytical models, which falls more into SAP, ETABS, and other CSI analytical applications. Something I'll describe more in later, a design model versus an analytical model can be very different. So sometimes when you need to merge these specific models together and sort of overlay the data and figure out what can be combined, ultimately generating a brand new model. Now, using the one-way methodology, it's very effective to sort of use it at the very early stages of a design project, like let's say during SD phase. You can take a model in the very first week and then immediately upload it to Konstru, and then while you're developing that model, someone in ETABS can download the model you uploaded and start sort of testing on it, right? And the good thing is all the metadata of the model is being kept. Now, as we see in the round trip on the left-hand side, if that model gets uploaded, then downloaded into ETABS, someone can merely just update the model. In other words, we can pretty much work with one Konstru model the entire time throughout the initial phases of a project, potentially. Round trips, though, can get not complicated, but can get a little bit more custom, especially when there's multiple changes throughout the design, throughout the development of the project, and so forth. That said, you can still work off one specific Konstru model, such as displayed in this diagram. For example, take a model from week 1. It's going to keep getting developed as the weeks goes on, but during that week 1, it immediately gets into ETABS. That becomes version 1. As they start to update it and edit it, the ETABS model will just keep getting updated from all the design changes of the Revit model, such as week 3, we have version 2. In week 5, we have version 3. And then they keep getting downloaded back onto ETABS, updating the model. And ultimately, once we have a satisfied series of responses from ETABS, we can then purely take that model and then update back into Revit. It's a little bit of a circular workflow, but it allows you to use one model and just constantly keep updating it instead of making various models, or other words, Konstru containers. Now, another thing that may happen is that sometimes it may branch off where you have more than just one model happening. So you might have SAP and ETABS doing different analysis work, and then you will have to basically create different models in that sense. You can still rely on the same Konstru model, but then it's a matter of last update wins. In other words, the model with the better data, of course, as discussed within the design team, will then be merged all together and updated finally back onto Revit. Now, this particular workflow is very much centered into Revit and the idea of, as you develop the design, as you develop the overall project, you're constantly updating the Konstru model and sending it to other platforms, doing all sorts of tests and changes. But then as you do that, you're always linking back into Revit, trying to update it with the latest information, latest forces, and so forth. And like I was mentioning before, multiple platforms might have to call for multiple Konstru models, which as well can be done. You can have a model solely focused just for ETABS and keep updating that one. You can have a Konstru model solely focused for SAP and keep updating that one. But the good thing is that they're all being originated from the Revit model themselves. So it's a series of 2 Konstru containers that all come from one. And then at the very end, these elements will be able to understand when they reference back the original Revit model that they're being updated. And it's very effective that way to sort of do management and do very various tasks and isolating models in that sense, and not having to sort of rely specifically on one model all the time. It gives a little bit of freedom and liberty for changes. Kind of like another example is, say for example, when you're doing round trips and you're developing different models on different platforms, question might become as to 2D documentation, such as your beam layouts. Your beam layouts are going to have different beam sizes depending on the analysis, right? So that's the option you have to then compare two different models and then coordinate them. Of course, that does require a little bit of manual work on the end, especially if you're merging between two different software platforms. But you are more than possible. Sorry, you have more than the capability to review the documentation and then sort of mix and match what is the best decisions based on these different platforms. And as the project goes on, such as goes beyond the schematic design phase, you can still continue working on those Konstru models and sort of redo the same process, merge them and figure out what is the best result between those specific entities. Again, this is all about extracting a series of models from Revit, creating Konstru containers, and then sending them off into different platforms and ultimately combining them back and bringing them back to the original Revit model, all for the sake of updating and maintaining sort of a, I guess in a way, mirrors the idea of the central model in Revit, maintaining centrality that way. So now there's no various endless models left and right. Kind of like I mentioned before, the idea of model merging, where if you have different models being created and edited and within Konstru, you have the possibility to merge them. Now, Konstru, it comes built in with the possibility to merge and read two different models and has a tolerance for understanding if a beam is slightly off another. If a beam is slightly located differently from its original location, it might be able to, or will likely be able to pick it up and assign its properties back and forth. For example, on the left-hand side, we have Revit week one model, and then we have a separate model that got completely generated in ETABS. As it's getting analyzed and worked on, it can then be transferred with Konstru and then merged. That way, the Revit model will just pick up all of the changes from the ETABS model, even though they both came from different origins. On the right-hand side, we have a diagram that says here's a Revit model that then got dispersed into ETABS, but then heavily edited and changed to the point where it's starting to have some geometrical differences between Revit and, well, the original model and ETABS. The benefit of this is that using the merge function of Konstru, you can quickly compare them and then make your merges together and then ultimately update the Revit model with all the corresponding correct information. One thing to consider when you're model merging is the ability for each model to be developed and operated differently. Like I said, you will have the ability to work on two separate models if need be, such as a model designed specifically for ETABS and a model designed specifically for Revit, and have those kind of work separately. But using Konstru, they can have conversations with each other regardless of the phase of the project, where using the merge components or the merge functions within Konstru, you can quickly take ETABS and Revit, put them together, and update the ETABS model, or vice versa. You can take the ETABS model, merge it with Revit, and then finally update the Revit model. It's really about using Konstru as a very flexible bridge, just trying to figure out what is the best benefit for the workflow. Another way is, of course, taking the model and then sending it and transferring it into ETABS for whatever reason, and then using that. So in this case, everything's coming from one original model and not being designed from two separate entities. Of course, this is all, again, these are workflows that you could look into, and you could definitely eventually develop your own workflows with all the different functions and flexibility that Konstru might give you. It's ultimately, like I said, it's a bridge between platforms, but how you use that bridge is entirely and completely up to you. We can keep adding more softwares, more platforms, and then eventually at any time, we can start having multiple models being compared and merged. So that way we can reach an ultimate final model, in this case, quote unquote, a central model, that can then be used to deliver the final drawings and final documentation required for any particular deadline, such as a DD submission or an SD submission. Like the examples I provided before, round trips and model merging can all be combined. And like I said, the idea of workflow and using Konstru can all be sort of manipulated to your preference in many, many different ways. You can have a model being originated only from Revit, and then that model gets sent over to ETABS. That model gets sent over to SAP, and then they get developed differently or independently. ultimately, let's say ETABS gets transferred in, and then ultimately ETABS and SAP both get transferred in, and like I mentioned before, reviewed and consolidated into one concise model that can then be used for deliver for design, development, or other phases. In a nutshell, it's essentially like looking at a BIM copy and paste sort of model merging, where you have your main construct, your main building, but then you're making changes in other platforms and other things. And sometimes you necessarily want to update the model, or maybe you're trying to just bring in additional elements that didn't originally exist in the model. Copy and paste in a way. You take elements A, or a series of elements from part A, a series of elements from part B, weighing plus main building, combine them, and ultimately you have a combined model that you can then download and distribute left and right. The benefit of this, like I said, is you can distribute this model anywhere, or you can bring it back into ETABS. You can combine models you develop separately in ETABS, SAP, Excel, RAM, and other applications that are being developed. Combine them into one container and then drop them into Revit. And Revit, Konstru is also intelligent enough to know of the sort of metadata and all these different properties that are being assigned, so they don't get lost in the translation. They'll be applied, kind of like what I'm trying to show with the right-hand diagram here with the beam layout and all of the beam tags and all that information. Are there any particular questions regarding workflows and techniques? We'll go over this a little bit more in detail in the examples when we actually start going through how to do this. But before I go there, are there any particular questions or anything? No. Okay. All right. Well, we'll continue on with tools and techniques and how to basically get the best of Konstru. Interoperability. So this is just a suggested workflow techniques going one way. If there's something I didn't mention before, Konstru is an interoperability platform. That's kind of like the main word describing Konstru. This bridge lets you not just go one direction, but both directions. Lets you go forward and backwards, or in a circle, and kind of lets you interop between many different platforms and not losing your data and maintaining that sort of model precise and well developed. In a nutshell of how that would work, if you do the simple one-way platform or one-way workflow, you take a Revit model, then you review it. It goes through the web interface, which we'll cover in more detail a little later. After it's been through the web interface, aka the cloud, then it can get downloaded to a desired platform. In this case, we put ETABS, reviewed, and then ultimately you have to go through a mapping dialog describing like what do we need to map from model A to model B if there's any particular changes. Here's a more diagram you guys can read over that basically explains a little bit more on what happened. So take the Revit model, you select a number of elements if you want to select only a certain set, like a certain selection, or if you want to select the whole entire thing, you're more than welcome to. You can review the model for connectivity, or you can actually emphasize connection selection, so that way you upload only an analytical model. Then you'll be presented with filters, which will be covered a little bit later, but filters will actually allow you to filter your selection a little bit more in depth. Let's say you only want to upload beams, for example, instead of just the entire model. That's an option you can be able to develop on your own. You can also create your own custom filters. Web interface, then after you review the model, you can then download it back and map it onto the platform. Again, you'll be presented with filters, asking you like, what would you like to map? How would you like to download? Or what items are you looking for specifically? And you can customize this again. And then once you've downloaded into the proper platform, then you go ahead and map certain elements back and forth. Oh, no, it doesn't have a video. I'm sorry, I'm supposed to have a video here. Okay, okay, we can keep going. So regarding groups and managing interoperability, so we all know that different applications have different ways of collecting data into groups per se. Like Revit has selections, SAP has groups. Most CSI applications have groups. Even Rhino and Grasshopper have their own way of taking a chunk of elements and considering them one entity or one collection. In this case, when you pre-upload from a Revit model to an ETABS model, you're presented with a partial upload. In this case, create a selection set or groups first, or you can upload the whole thing. Now, don't worry, like I said, Konstru has the ability to convert all these particular conditions to something that the other platform will be able to read. So a group of objects on the Revit side will be automatically converted into a corresponding group of objects on the right-hand side, ETABS. In other words, a selection set will be converted into a group set. Allows you to maintain organization, especially if you're very meticulous about like certain groups of different parts of the projects. Another thing is sometimes you want to work with these particular groupings and selection sets, so you don't want to upload the entire model, because also based on your Wi-Fi capabilities, your internet capabilities, or whatever you're given at the moment, uploading a large, massive model might be counterintuitive. But of course, with the possibility to select exactly what you want to upload, whether it's groups or a custom selection, you can go ahead and do that and make a Konstru model only with those specific objects, and that will be transferred over. Now, before you upload something, you'll be presented with this dialog that says, would you like to upload a selection? And then you can select a specific selection this way, name it something, or specify it, and then update Konstru. And on the right-hand side, you'll notice that you'll be able to ask, it'll be asked if you want to upload an active selection, or do you want group A and group B? Now, when you're uploading stuff into Konstru, there's something very important that has to get covered regarding interoperability, and it's connectivity. Model connections. For example, I'm not sure if everyone's aware of how Revit works with models, or how certain models are prepared for certain CSI applications or analytical applications. There's a little bit of a difference between a physical model and an analytical model. In this case, some models might look like a certain way and they won't actually be connected in other platforms. What I'm trying to say is something in this diagram. So we see that on the left-hand side, we have a little Revit, tower, call it, and then you see the little blue dots. The blue dots is what's represented in Revit's physical model. And sorry, apologies. And the red lines represented is called the analytical model. Analytical models are basically a collection of finite elements that are defined by 2 points, and those 2 points are then always interconnected to allow the analysis to run, because the analysis needs to have awareness of what point is connected to what line and what that line represents, and so forth. One moment. And then in Revit, on the other hand, a model line can be composed of a lot of different characteristics and metadata, such as offsets, pullbacks, and other geometrical manipulations to allow it to look like the way it should look. As displayed here, we have our blue line often seen in Revit, which is a physical connection, versus the analytical connection going to a sort of midpoint of the element, breaking the element in two realistically, and always ensuring connectivity. Another example of what we're trying to say versus a Revit model and an analytical model. Analytical models need to always have a connection of points. Revit models, in this case, are custom 3D objects. And this is just an example. I'm not going to go too much into detail about this, but this is an example of how Revit reads certain models and defines connectivity. For example, if you have a wall that's composed of different levels and whatnot, that's how it would have to be broken up into 3 chunks. If it's already designed like that in Revit, that'd be useful. If not, it would have to be redefined less so. For example, a wall to floor condition, and then we have a column to wall, where if you have a column sitting on, or a column to relationship, that has to be defined as a center point that would have to get split, and so forth. Another particular property, well, this is again more details, and you will be more than welcome to review this PowerPoint later on. I'm not going to go into depth about this, but essentially it's just discussing the idea of versus what happens when you have an analytical model versus a non-analytical model, such as a Revit model. And these are just a series of options you can start to develop as a filter to then within Revit, you'll be able to review your models as you go, making them appear as analytical, and you'll be much, much more aware of what's happening if you're transferring it over into ETAB, SAP, or any other CSI-focused applications. Now, using the filter, you can easily review the connectivity and then quickly see if your models are connected. Again, Revit tends to focus on creating realistic models that can be used for, well, any purposes really, versus analytical models are more specific just for analysis, and they need to have certain connectivities. They don't want pullbacks, they don't want these offsets, they don't want join or unjoin elements. They want just a simple line, finite elements with point connections. Now, one thing I do want to mention regarding Konstru and Revit is that it does use the default program library that you have, but you can also bring in your own custom libraries and your own custom families, essentially. By the certain dialog you have here, you'll be more than welcome to introduce certain templates, certain families, and Konstru will read them and bring them up to the cloud, and we'll understand them. So that's if you have, like most companies tend to always have something custom or their own specific locations, you can go ahead and add them in with the Konstru dialog, and then it'll be supported directly. Now, going back to the join condition, a little video that explains this, but essentially, like I mentioned, analytical versus join elements, as we all know in Revit, when you join an element, it gets pulled back and it responds to its sort of physical distance between each other. But when you unjoin something, you'll notice that the analytical lines in this case are actually touching as they should be when you click on a particular model. Now, this isn't preferable when you're using Revit because you want to have those joins in Revit to allow your beam layouts to appear correctly, your drawings to appear correctly. And then using the unjoin and join command, we can quickly edit this and manipulate it as such. And this is kind of showing the idea of how Revit understands certain things and how things are joined versus how you can use that to your benefit in regarding analytical models. Again, here's a little slide with a little bit more detail regarding what joins means for those who are not very much aware. It's a series of cutbacks and pullbacks that are applied to linear elements, and then after the linear elements are being read by Revit, they'll get swept and applied a 3D profile with the specific justifications and cutbacks. Now, when you're downloading from analysis to Revit, which is kind of the other way around, you will have to have some filters, or you need to apply some framing join to achieve the intended 3D look or 2D aesthetic of an object, and that's just kind of native of what's happening from when you're incoming from an analysis application. For example, if you're taking an application from, a model from SAP or ETABS and it's brand new and you want to bring it into Revit because it looks really good, once you're in, you're going to have to either join them so that way you can start getting all those pullbacks correctly and everything appears as they should in 3D and 2D, or otherwise do some little bit of manual work. Now, one thing I want to say, the framing analysis and framing connectivity is not built into Revit. That is something that's provided with Konstru, which is to your benefit, of course. And it'll let you sort of alleviate some of these little pains when you're joining and unjoining elements and making things look the way they should. Lastly, when you're downloading something, here we're going to talk about in terms of transitions. When you're uploading and reviewing models, first, when you're uploading a model into Revit, you'll be presented with a review. A review is this dialog at the bottom here, which says what is about to happen in my Konstru model. It'll read your model and then ask you a series of questions or a series of little drop downs that say, hey, this is supported, this is not supported, this is absolutely not supported. In this case, some elements aren't going to get transferred over because they're not properly supported versus the elements such as floor, wall, column, beam are definitely getting transferred over into the Konstru. Once they're in Konstru and then you want to bring it down and bring it back into the desired platform, it'll tell you the elements which can be supported and brought in and which aren't. In this case, load patterns are somewhat supported, and then floor, wall, column, and beams are very clearly supported. Now, you can also have the option to delete existing elements when you upload into a model, and based on the filters you have set up, which is what I was mentioning earlier, is how you can customize certain things that are being uploaded and downloaded to a particular container before sending it to another application. You can then determine what other elements are being uploaded. On the right-hand side, you have a little filter diagram, which says all data allowed, data prevented by platform limitations, and lastly, user filter preventing data. So we see the load pattern is not going to be sent over into the Konstru model because we have a current filter, in this case the default, that is not going to allow the particular data to get transferred. Again, this can be edited and transferred on your own, edited and manipulated, and you can set it up custom so that way you can allow certain data. Now, if you have the middle icon, which is data prevented by platform limitations, that will not get transferred into a certain application purely because it's not supported by that application. Now, once you finally get to review your upload before you finally press on the Look, Skip, Proceed button, you'll be presented with a series of options that says New, Updated, and Deleted. New says any particular element that is brand new. Updated says any particular element that has been updated with a new profile or other metadata. And by clicking on the little question sign, you can get a little deeper into that specific update and look into what is happening there. As here it says, before this beam was deli 14 by 26, after the beam has become a 16 by 32. When you see object deletions in the software, or across softwares, I should say, what happens here is that when you delete a model or delete a piece of your model in Revit and then you update that model in Konstru, you'll notice that Konstru will read that ID and say, hey, you have taken an element and deleted it. You can also you have the option to completely delete the element by selecting the delete existing element, or you can deselect it and it'll leave it there. It won't actually delete it despite you having deleted it in the original Konstru model. It's giving you the option of enforcing the deletion of elements or retaining them within the Konstru model as you update it. Now keep in mind, if you delete something from a Konstru model, it'll be deleted from a specific version, and then if you download it to any other platform, it will also be gone. Filters, kind of like a little bit, I've already mentioned some of this as we were talking about it, but filters is a way of managing your data, customizing it a little bit more so as it's being uploaded and downloaded between various applications. For example, when you apply a filter, you can determine how much of your data gets uploaded, what kind of data gets uploaded, and what about your data is getting uploaded and sent over to other platforms. Like I mentioned before, you can alter what's getting uploaded and downloaded purely based on your filter, and you're presented again with these icons that determine if something's completely allowed, something's not allowed at all, and some things that are allowed but then being disabled purely because of your filter. Filters allow a high degree of control. Again, it allows you to sort of establish certain elements, focus more on certain attributes, certain metadata, and certain conditions that can go in and out. And for example, there's a lot of pieces of metadata that cannot go into Rhino, but there's a lot of pieces of metadata that can go between Tekla and Revit, for example, or Revit and Excel, or so forth. You can also share filters via models. Once a filter is added to the model, it can be used by any other Konstru user who wants that model shared with them. In other words, if you make a custom filter and you share that model with the filter to another user, that other user will be able to use the same filter on their own. They pretty much exist permanently once you create a filter. It's also good during a project because it lets you sort of change different things as you develop the project, such as an SD and DD phase. You might want to be concerned about different elements getting transferred over versus just kind of transferring everything over and so forth. One thing to know is there's two kinds of filters that come in, almost like preset with Konstru. So there's a kind of filter that you create. You can obviously define all the custom filters you want, as many as you want. And then, of course, there's a series of non-editable existing filters that come with Konstru, the Konstru recommended filters, recommended uplift and SAP from ETABS, from Excel and RAM. You can also clone those and edit them and use them as a guide. Start using those as a base to edit and design your own filters so that when you're uploading and downloading data, you have a little bit more of a sort of upper hand besides just starting from scratch. When you're creating filters, you're presented with many, many different options, such as the name, the description of what the filter does, whether this filter should be considered a default when you're translating between Revit or other applications, and what the filter does. In this case, at a glance, you'll see these little buttons that mean material, property, name, and geometry, which if you turn them all on, that means they're all allowed as they're getting transferred to the specific element. So to break this down again, we click on beam and we say beam has all of these members allowed, which means when a beam gets transferred using this filter, all the following properties can either be ignored or allowed. And you can also add custom attributes that can be searched for whenever you're transferring data over using the design and invented filter. And again, this is kind of like completely up to you and how you design it, how you devise it, and how pretty much you customize it. And it's relatively endless. You can edit it, so forth. And again, once you make a filter, you can go back and edit it. It's not like a final done and done. You can clone it and share it between different users in your team. Of course, there's some things that just can't be sent over to different places, such as Revit levels to SAP. Certain elements and certain conditions and attributes between certain platforms just don't exist. This is a well-known caveat of pretty much working across platforms. With that said, the point of Konstru is that it notifies you about these elements, notifies you about the pieces of data, and lets you know if something can get sent over or it cannot. But of course, most importantly, why we develop Konstru is to take the most important data and ensure that it can get delivered between places. Here we have an example of what would happen if you tried to send over levels into SAP. Well, simply they would just not exist. There would just be an error generated that says, hey, we can't generate levels, so therefore we can't make them. But with a design filter, you can quickly filter them out and avoid getting any errors upon download or upload from SAP, or upon downloading something from Revit with a series of levels. This is also another way of using filters to sort of ensure quality control between transfers and not just not sort of let the application error out, for example. You can also filter object types that are used by different analysis engines. Custom object filters can be used to prevent certain types from translation, oftentimes easier than creating a group that can while maintain a single source Konstru model. Again, a simpler diagram saying download, ignore floors, this will take a filter, and it comes in and it takes the floors and beams, and then you can have another filter that says ignore beams and floors. So you have two particular filters that you design for two particular applications, which then this can be used also as a way to sort of dispatch and disperse your information and elements from Revit to go to their appropriate places and get sort of analyzed and used appropriately, instead of just sending everything to one and sending everything to the next application and so forth. Again, filters let you customize a little bit, be even more organized when you're sort of transferring data between certain applications and softwares. One thing to note is that, kind of like I mentioned before, analysis versus physical models is always driven back to connectivity. Physical models, such as those based in Revit, have many, many, many different conditions. Like I said, details and conditions and pullbacks and offsets and justifications and so forth, versus geometry that is connectivity driven, such as analysis, is always focused on just that interconnection between elements. Of course, using a filter, you can sort of emphasize these particular conditions, such as just give me the line with the material, the property, and name, and not the geometry. So only the data can be updated into a specific element and not the geometry itself. Another thing that you can do is kind of endlessly loop around using the attributes. So attributes in this case can be referred to when you click on an element in Revit and you see the parameters. Those can be often referred to as attributes. You can add more parameters to a specific beam, for example, and constantly update it. The good thing is you can use this to transfer to other platforms as well, such as SAP. They can come in and out. In other words, profiles, many other model attributes are used explicitly in analysis, while they can be user-defined in Revit and have no real requirements. For example, forces, if you define a series of forces in Revit or a series of parameters for forces, you can take them from SAP or ETABS, and then they should be able to be read back and plotted back into Revit. Okay. Again, kind of detailing more about property mapping and all these things, is that when you go from one application to the next, you can quickly cover mapping. And mapping dialog is sort of taking a series of metadata from application A and asking you to sort of refer to the right locations in application B. For example, model B has the following metadata, and when you're being mapped over, it's going to try to ask you, what does material A refer to material B? This is what the mapping dialog looks like. Incoming, when you're downloading to ETABS from Revit, you're going to be given all these particular parameters. So it says, oh, there's an incoming type from Revit, and it's 4,000 PSI or we have a metal decking or concrete cast in place with 4,000 psi again. Now, it's going to search your available model in ETABS and say, this is the options I have available. Would you like to map certain conditions to these? So that way it can read it properly, or you have the option to create something new. It's sort of like a best match. Konstru will always automatically try to match your models as best as possible as it can, including to any kind of metadata that's assigned with them, materials, areas, profile sections, and so forth. If something doesn't exist between two models, the mapping dialog is kind of here for your benefit, asking you to remap something to the right place. Otherwise, you can also create something new. So that way, when you map that data over, it's being read correctly in the proper application. One thing you can preview before mapping all these things is just taking a look at the web interface. The web interface allows you to visualize all these elements and get a better sense of what's going on and understand sort of all the metadata that's behind all your particular models before you go into any application. You can also visualize them by color, and then you can go by default, change, type, material, profile, geometry, rotation, and attribute. As displayed here on these screens, we have W57 as an example that lets you get an idea of what different displays you can go to when you're in the web app. One thing I could show for a second is the model itself. How do I move? Here we have W57 as displayed, and we have the viewer over here, and we have a series of different metadatas. And again, we'll go back to this model a little later, but just wanted to give you a sense of what the screenshots are showing, where if you switch over into a different condition, you can visualize all the elements by a specific sort of category or visualization condition, and then you can click on something and get metadata from it. As we see here, we clicked on a particular element, so a column, and it tells you what kind of profile it is, what kind of concrete it is, and other additional attributes that were given to it when it was being transferred and developed. What is it doing? Okay. Sorry, my apologies. Why are you switching over? Okay. Back to the model in 3, 2, 1. Okay, so back to this, like we were saying, the web interface. Like I was just kind of quickly showing you using the model as an example. You can also have the option to go between different versions. When you go by change, it'll say, would you like to view the change of model version 1, version 2, version 3? And then you can also compare between them. And you'll be given this dialog on the right-hand side, similar to what I showed you on the web interface, saying 2,000 elements got changed, about 2,000 elements got added, and about 1,000, or actually close to 2,000 elements got deleted, and 900 elements got updated or so. And this is something you can do quickly by just clicking on the view by change and then being able to compare between different versions of any particular model you develop in Konstru, no matter how many times you update it. You can compare version 1 to version 15, doesn't matter. Here's a preview again of the web interface. It's kind of showing a little bit more of like what I was trying to demonstrate right now, but in this case, we're looking specifically at the model differences. In this case, we see that a total of 1,000 beams got changed versus a series of other beams didn't get changed. But then anything highlighted in orange just shows any updates. Anything highlighted in purple means nothing got changed. We see 16 got deleted and about 1 element got added. And of course, if you go again to the view by and change, you can emphasize which model you want to compare it against, and it will automatically distribute a list telling you what got changed, what got updated, and you can click on the given element and notice what about that specific element got changed or updated. Also, when you're in the web app, you can create various models and you have the option to create permissions. In other words, let's say you have an organization. For enterprise kind of organization, you can say anyone within a specific organization has access to this specific model. If you make a Konstru model and you don't want to sort of share it across the whole enterprise, you can specify people who only certain people who have access to the model. In this case, on the bottom here, you can invite a user. And by inviting a user, you can have them access a specific model and then give them a certain permission. Of course, if you're the author, you're automatically going to be considered the owner. And anyone else who you want to have similar permissions as yourself as the owner will be considered an admin. They can invite collaborators and change the model, update the model, manipulate the model, and so forth. You have modeler, people who can purely just update the model. They can't delete it or anything like that. And then you have viewer, people who can just see it or download its metadata. And then lastly, limited, people who can only see specific reports. And reports means just like a sort of version of the model, nothing more. It's very useful when you're sharing models that have particular sensitive data, whether it's across teams or whether it's just between certain conditions like engineers or sort of just architects or back and forth. It doesn't matter. It's up to you to use the sharing as you like. Here's a little bit of sort of an animation showing you like filters and showing you something that can be inherent into your organization. You can specify the length unit you want to always work in, the force unit you want to always work in, default setting for certain Revit parameters, such as the forces. And you can also go back and look at your models and then edit that back and forth. You can invite people to your organization directly. So that way they have access to whatever models you have on your screen, as well as, like I said, model-specific invites. We have a little video demonstrating what happens when you go between Konstru and Excel. Now, as I mentioned early on, the ability to go between Konstru and Excel is kind of inherent. It's part of Konstru because, like I said, everything that goes into Konstru at the end of the day is just tabular data. As we see here, we're going to have an example of the Cornell Tech. So I can just show you a second. We're going to take an example of this particular model here and show you what happens when you can download it onto Excel and how that operates. Let me just play the video. Let's do that. So again, the specific model you saw, Excel has a built-in, or not built-in, we provide a built-in plugin that you can bring into Excel. You can download the particular model, and then when you download the Cornell Tech model, in this case, you'll be presented with something similar that I presented in the very beginning of the presentation, a series of Excel sheets with a lot of tab data, such as the columns, all the beams, all the lines, all the walls and floors. People who often deal with CSI platforms are very familiar with this kind of setup, because when you export something from SAP or ETABS, you're often given a gigantic Excel sheet, or you can customize it, of course, with all of the data you need for any particular element, such as endpoints, locations, whether it belongs to a certain group, or just, I mean, it's kind of infinite, really. What all sort of data attached to a certain element. And this is an example of what happens when you download data from Konstru. Also, you can take a specific data, I'll leave it here. You can take a series of data downloaded from Konstru. And again, when I say this, I mean a model you uploaded to Konstru, upload it to Konstru, and then you just want to download it into Excel. When you download it to CSV, it appears like this. You can also edit it. You can add custom attributes directly through Excel, shown here. For example, in this case, we took the M3, and then we developed a series of new tabs that could then be a series of formulas. And then by naming these columns to match the Revit parameters, we then create a link between the two. The factor values will be written down to the name parameter and Revit on the next download. So you can take this Excel sheet, upload it back into Konstru, and then update your Konstru model through the text only. And then when you download this a newly updated model onto Revit, you should see the data update, such as displayed here. That's just simply another format, another way of using tabular data or using Konstru in a more sort of data-focused version instead of just geometry, and how to edit it. Kind of a little bit more of what I just mentioned, showing you how you can read certain things and then sort of dictate, reapply them back to the Revit parameters in this case. And that sums up a lot of, I should say, a lot of how to use the interface. Now we're going to jump into some, oh, sorry, I didn't notice the chat, but that applies a lot of the basic workflows in how to use Konstru as a bridge between different platforms. Interoperability, essentially. And thank you, Nick, for answering my question. Now we're going to go into practical examples. Before I go in, are there any more questions besides the one on the chat or anyone on Slack? No, I just saw Charlie's questions. Are there any other questions on the Slack channel? Let me see. Or if anyone has a particular question now before I proceed forward, we're going to go into editing models using Grasshopper, Rhino, and ETABS and Revit. All right. Okay. All right. Well, without further ado, if there's nothing left, we will continue on to the practical examples, showing you how you can quickly and effectively, using Rhino and Grasshopper to start, create a one-way flow, creating a Konstru model and updating it. So there is a series of example files provided, which I'm sure you guys might have should have gotten in the Slack channel as well as in an email potentially. If you haven't had a chance to look at those, now is the time to open them up. Assuming you got Konstru installed and up and running, we can talk about how that works. But of course, I'm going to run it through on here. So in this case, we're going to start specifically with the 0-1 Konstru one-way basic, one-way translation basic, and I'll run through what all this looks like, as well as the ribbon itself and the components. After you successfully install Konstru into Rhino and Grasshopper, and you have the ribbons installed on Grasshopper, kind of like portrayed on my screen here, they'll be located in the Konstru ribbon, Konstru tab or K, and you'll be presented with a series of components that go from the creation to extraction of a particular model. You can go talk about models and then get models, versions, stats, and IDs. You can extract or create certain profiles, as well as read them back from a library, which we'll cover in a second. You can also have a series of parameters that can be used to transfer data within Grasshopper, sort of like you have a point component here. We have something that can be called a structural profile component that just transfers structural data between components. And lastly, we have a series of utilities that allow you to do justification, catalogs, and other CSI and RAM focused components, such as loads. Now, you don't need a lot of, or very much at all, Grasshopper knowledge to use Konstru in Grasshopper. It's fairly simple and fairly straightforward. If anything, you would need to know how to reference data into Grasshopper and how that kind of can tie into the Grasshopper components, and then ultimately how to send that up into the database, into the Konstru web. Now, in this Rhino model, which should be provided as well in the folder that is in the Slack channel, as on the emails, you'll be presented with two very simple things. You're presented with a curve that represents a beam and a curve that represents a wall. We'll talk about a little more how that works. But essentially, to create a beam, you just bring down the beam component. It can be found up here, and then you'll be presented with a series of conditions such as profile, curve, and justification. Oftentimes, a lot of these are preset with default values, or sometimes there's empty because they're not needed. Otherwise, you will have to specify at its basic at least a curve, sort of defining its linear representation, analytical representation, and then refining it a profile, so that way it gives it something to create. In this case, we've selected a profile here, W14 by 90, and then that became our standard profile, and then we go ahead and create that element. Now, as you see here, when you hover over the element on the right-hand side of the component, you'll be greeted with something that says Konstru element beam 1038 feet and W14 by 10. Now, this is specifically Konstru data that would then ultimately get sent over into the upload Konstru component, which can be found under model, upload Konstru component. I'll talk about this in a second. Just want to get past this. For those of you who are not super aware of how to use Grasshopper, how to use or how to even like get through Grasshopper in general. For the wall, in this case, we don't need a lot of stuff. We just need a curve defining its origin, its center curve, in other words, and then we need the height. Sometimes Konstru comes in, or not sometimes, I should say, it does come in with a default value, even though it says empty. If you don't give it a default value, it'll automatically assign it a specific value, but of course, you can go ahead and assign it your own and give that wall a specific height. Now, once you set this up, you can collect all your data. Grasshopper has a function called merge, where you can just collect data and input it into what's called D1 and D2. You can also, as you build more components, you can add more data. Let's say in this case, like hypothetically, you wanted to add a column. You would bring down a column and then build it from here, and then go ahead and drag this there. We'll talk about that in a little bit, but in this case, just showing you the basic workflow, I have to create a really simple Konstru model. Once everything's set up, you can simply just add a comment to the message box, add a button to the upload, so that way you can just trigger the update. Make sure the data is connected to the update elements. And lastly, model ID. This is kind of the most important one because it's going to determine where all this data is getting sent to. First thing you want to do once you've finally created all your models is that you want to create an empty container. Kind of like how I mentioned before, Konstru is basically a series of containers that data needs to go into. So you can go to the Konstru after you successfully logged in and create a new model. Test one. Test one, simple. Simple, or sort of basic model. We add a description. We can say JS test, and then we create a model. Once we made a model, it should pop up on your dashboard and it's not automatically go into it. You'll be greeted with an empty container, in other words, the series of other data you can look at in the video. Now, once this has been updated, you can go back into your Grasshopper, you can select a model, and it should update and not show up right on top, because the latest model, it's always sorted by date. The latest model you created, so AEC Tech Test 1, basic model, we can go ahead and select that as our desired model. You'll see this light up, and it's no longer red. And once that's all good, you can just press update. It's going to basically say you've updated the model or created a model with new two elements, a beam and a wall. Looks good, proceed. Now you have the option of clicking done and just kind of going back to your work, or you can view the model. In this case, we want to see the model on the web to see how it updated or how it created it. It'll automatically take you to whatever your default browser is, I believe, and then it'll demonstrate you your model. You have the option to, like I said, filter through all these particular conditions, such as the profiles, and get a sense of what's what. You can click on the element and understand what it is, as well as the wall, and get any particular elements. And if you ever wanted to get a sense of like what the wireframe looks like, you can go ahead and go wireframe view, and it should represent you the analytical lines that were used to create those two models. Again, that's wireframe view, and to get out of it, you just click on it again, and you'll go back to the standard web viewer. Now that is a very simple sort of creating something in Grasshopper using existing geometry, such as these two lines, and then turning them into Konstru elements and uploading and creating a basic model. Now, the next thing we're going to cover is basically how to update a specific model. If you guys have if you guys have the files on hand, you should go ahead and open the O2 Konstru one-way translation basic with update. Now this will see how we can take an existing elements and, like I said, update them within an existing Konstru model, something that you should have created once you have access to the Konstru interface. So we're gonna reference back this model that we created, AEC Tech Test 1 basic model, and use that as our main model to update. Now before we do that, we're gonna take the series of elements here and then do a couple of changes. So in this case, we're going to say we created a beam and W14. What if we just change the profile? Change it to something very different, such as this one. This is how you can add. This is also showing you how you can add specific sections to a profile. And then once you brought something in, select the arrow, brings it in, and then you can click on the one you brought in before. You can select the arrow to take it back. And keep in mind, of course, this is tied back to series of catalogs, which is if you're in other countries or you just use other catalogs, you have the option to read through them. And also you have the option to look at other standards such as L's and M's and HSS's and pipes. Feel free to browse it on your own once you have the file open. I highly recommend it, so that way you see the sort of extent of the library of Konstru. But otherwise, once you got a desired profile in, you just press OK, and you should see this update. It updated the profile, it updated here, and we should see the element change. We also have an attached here to sort of move the geometry in some particular direction. In this case, we're moving it 10 feet in Z, 0, 0, 10. And we're going to have that become the new analytical curve for it. To show a change, I'm going to highlight the original curve down here. And as you can see, when I click on the move component, the new curve is now highlighted up here. Now, when we update this model, we should see the model update with profile changes as well as location changes. And for the wall, we're also going to do something a little different. We're going to extend the curve in both directions. As you can see here, that's getting applied to what's called the update component or update wall. And if I move this over down to make it a little bit easier to understand. The reason why we're doing this post here is that we want to be able to take the elements that Konstru has already in the model and then just purely update it with a specific condition. Now that I put the model in, for the curve in, we are going to do the same process we did before. plug in the data in the correct spots, and then set it into the Konstru database. We're going to go ahead and toggle this on. We're going to get a little red flag because it says, oh, the model's not found, but that's okay. You have to select the model. In this case, we already have a model made, which is the test model we developed. Basic, enter. And then once that's all good, you just press the button and it's going to bring up a new dialog. Dialog is a little different this time. It's going to say updated 2 elements, and it says geometry change, which means the physical location change, and also the length of the change for the bottom one, right? We only change the profile for this one and its location, and on the bottom one, we just change its overall length. Once we're satisfied with what we see here, we can hit look to proceed. Now, of course, if you want to dig deeper, you can also press the little button here, and it tells you more about what happened. We had it previously set at 14 by 90. Now we set it at 40 by 249, and as well as its coordinate locations for the geometry. You can click on the arrows to filter through the rest of the geometry, in this case wall, along with its Konstru ID. Don't worry about that if you are not on the dev side, but essentially it's just how Konstru reads objects. Lastly, it's just letting you understand and be very explicit about information as it's getting developed across. That way you have full control of what's going on. Anyway, once you're sasatisfied, you can hit look to proceed, and it's going to go ahead and commit the changes. And you can either press done to go back to work or view the model. In this case, we want to see the update. So we're going to view the model. And as we see here, we have the existing geometry we can see has been altered. And if we go by view change, we notice everything's been highlighted in orange because it's been changed. Now, if we click on it, on the specific model, we'll notice that geometry got changed because it started and ended at 3 feet differently. Points differ from the original version we had before. We click on the beam, we'll notice that the same thing over here, it got changed, the basic property. Again, you can go ahead and change this conditions to view however you like, but that's the basic workflow of how to update. Now, there's one more file that I'm not going to go too far into because I do want to get into talking about ETABs and how to transfer between platforms. But if you opened up the files provided in your folder, there's one last one called 03 Konstru one-way translation homework full tower. Homework if you so desire to explore after the workshop. But essentially, it's going to produce something similar to this, not exactly this, but it's essentially a funky looking tower that exploits a lot of the existing components within the Grasshopper Konstru ribbon, such as the create element components. In this case, we can create custom levels. So if I turn these on, you'll see those green points that were highlighted. Those can then be transformed into what's called levels, which Revit will read a series of levels. And that's purely by using the level component, which all it requires is a height and it requires a name. So once you look at the output of that, it'll say Konstru elements, level something, Konstru level 0 with 0. What is that, milliliters? Oh no. It's, again, by the way, it's tied back to your Rhino unit. So make sure you're working in the correct units when you're developing things. Same thing for this. You can make a grid. If I look at the existing here, we have a series of grids, which will be read back in Revit. And you can go ahead and name those accordingly. So we have 4 lines, we have A, B, 1, 2, and then that's going to be a series of grids. It's going to be read back in Revit. And it keeps on going. Like you can do that for floors. You can build a series of floors, as you can see here. Floors are fairly simple. They need a existing surface. And then after you get an existing surface, you give it a particular thickness. It can be specified here with T, and that becomes a Konstru element of a floor. You can also give it a shaft opening. So if you have a particular floor and it needs an opening, you can go ahead and assign that by using, in this case, a BREP. I'm not going to go too far into what all this means in terms of Grasshopper logic, so I'm just going to give you an overview as to those who are a little bit more advanced. This should be familiar to you, and also showing the basics of certain components works. Essentially, what happens here is that you can keep endlessly customizing and creating a complete Revit model or Konstru model that can be used in Revit or other applications using Rhino Grasshopper. Or even download something and edit it using Rhino Grasshopper. If you need a little bit of custom work, this is going to be your go-to here, especially if you're doing custom framing repair that doesn't abide by the standard framing logics applied to Konstru, or any other particular custom work you desire to do. The best way to do it is by going into the nitty-gritty of Grasshopper and decomposing all the Konstru data into the respective elements and editing them as you like. Also, additionally, I want to mention that it does have support for adaptive panels, as we can see here. All the panels shown on this particular tower are a series of adaptive components that then can ultimately be sent over to Revit and have them be parametric. So or quote unquote, sort of Revit's version of parametricism. If you want, I highly recommend you try to upload this and put it in a container. We'll go through it right now really quickly, but like I said, this will be just another example before we jump into the cross-platform explanations. If you haven't, so tower, we can say AEC Tech tower test. One moment. Test. Let's see how the empty container. We can go ahead and select that. Now, when you actually get to play with this particular definition, even for those of you who are not familiar with Grasshopper, I recommend you just edit all the parameters, the sliders, and play with those things. So that way you can go ahead and upload your own custom limit tower and get a sense of how that works. It's a little bit more in-depth example than the previous one because it gives you an idea of how to generate models from scratch and also how to generate, or it's not how to generate, how to view data and deal with it in various forms. As you can see here, it gets fully constructed, and we can view it by the particular properties and different profiles that have been assigned to it. And we can click on a particular element and then get a better sense of what's going on where. As you can see here, no particular attributes or anything have been assigned besides profiles. This is a generic model, but again, I just wanted to establish the fact that you can make a simple model and then use that as sort of starting point for either Revit or other applications. And like I said, please do try to play this on your own, and I highly, highly encourage you to play with all of these yellow highlighted things, like the graph, for example. If we were to just, as a really quick example, we're just change this really drastically, you'll see the tower change, and funky, but you see the tower change, and then you can go ahead and upload that and update that. Now, encourage you to do that on your own as we go, as that's a funny way of saying homework. And now we're going to go on talking about the following example, which is going to be kind of like the bigger example of Revit, which is not Revit, sorry, Konstru, which is how do you go between Revit and ETABS, cross-platforms. So we can go ahead and open, not that one, okay. Okay, so if we can go ahead and open our, again, all the files I'm displaying on my screen should be provided to you, so you should be able to clearly just open them and interact with them. So in this case, we're going to start with our Revit to Konstru, create a version, and then go to ETABS, make some changes there, and then update that and bring that back into Konstru. Bring that back into Revit. So let's say we take this particular model here. If you manage to get Konstru installed, it should pop up here, and then you can go ahead and download it. Again, let's make an empty container. Okay. Tech Revit model for ETABS, and then we hit create model. Empty container, good. We can go ahead and Konstru. And okay. We can go ahead and select our particular model here. And then we can press on the update. In this case, since we're just creating a brand new model, we can go ahead and just press update. We can name it anything we like. We can just leave it at upload. And then since we're taking everything in for now, we can go ahead and leave that as it is, update Konstru. We see all the changes here, a brand new set of elements. Looks good, proceed. Sounds good. We don't need to view it, but we can if we like. And you're presented with an existing with a model we uploaded from Revit whenever it decides to upload. It's a little slow sometimes, but it's okay. If it starts to lag a little too much, you might want to just hit a refresh, or it'll just pop up instantly. That's also good. Just be aware of that. It also depends on your connections, so keep that in mind. But once we have our model in Konstru, now we can go ahead and we can go to eTabs, and then let's make a brand new model. And then use the standard settings. In this case, I'm bringing everything in. So blank, we're greeted with her 2 empty windows. We don't need that window. And we need the window. And then we go to my Konstru eTabs plugins. Yes. We take our model and we go ahead and download it. It's fairly simple to go between platforms. It's fairly straightforward. It's kind of like the intention and beauty of Revit, if not Revit, so Konstru, if not like the best part of it, where it's supposed to be kind of like a seamless transition between platforms, and of course, you'll be able to see all of your property conditions. Gives it a minute to apply and take all the particular changes in. And again, if you remember the previous parts of the presentation, all of these dialogues should be familiar to you. You'll be greeted with a couple of things like the material got automatically remapped to 4,000 PSI. Like I said, Konstru will try to do its best to map everything correctly, and if it can't find something, it will automatically map it to something new and allow the application to read it back. And it'll say plugin successful. And one moment. I need to set up my 3D view. There we go. So, and that's kind of like the simplest way to explain how to go from one application to another. Like you've just updated it. Now, let's say if we want to take a particular series of elements here, like say we take that particular beam, and then we change the section property to something else. I don't know, maybe anything else for this particular reason. Put them at 22, and then we take another one here. Okay. And then we also change that one to anything else. And again, we're doing this for the pure intention of being able to see these updates in Revit. Let's go ahead and we updated that, hit OK. Once we're done with this, we can go ahead and use our Konstru plugin, hit yes. Since we already know what model we're going into, because we're looking at an update purposes, we're not, we don't need to create an empty container. We're going to take this Revit model for eTabs that we built, hit select. Now in this case, we're going to update Konstru, and then we can leave everything as it is for now. And then you'll notice a series of conditions that got changed, updated, and whatnot. In this case, we might want to do something for a filter. In this case, we could say we want to create a custom filter that will let us avoid sending in particular conditions, such as the manually mapped material. So make a new filter from eTabs to Konstru, and we say, I don't know, remove materials in this case. You can add a description if you like. Removes eTabs materials. Template recommended is fine, or you can kind of customize it. And then you hit create. Now we're not quite done yet. We have to go edit that particular template and then make sure our materials are not sent in. So when we go, let's say we just kind of wait for beams. Don't send that in, and then we edited a column, so we'll go ahead and send and not send that in either. Now again, this is kind of like a live demonstration of how to edit and create your own custom filters. You can go ahead and do this endlessly on your own, and like I said, I highly recommend you do this with the example files provided. Once everything has been properly done, we can go ahead and hit save. Take off all the material properties here. Material. Hit save. And now we have a custom filter we created that says remove eTab material. Cool. We can go back to our model and then select that filter. Remove materials. And it's going to go ahead and update it by such, and then look to proceed. We can view our model if we want. We don't really need to, because we're going to view it anyway in Revit. And then Revit here, we go back to our original model. We can go ahead and hit Konstru, and then take the same model we were working on again, because we're doing updates, and then we go to download to Revit. We're uploading. It's already telling you there's a new version online that you have at the moment, which is good news. I'm going to go ahead and download it. we'll notice that there's a series of new elements that got changed, updated. We updated 2 beams, which is correct, and then 1 particular column, which is also correct, and then a series of new conditions got added that came in from ETABS, so particular load patterns and whatnot. Materials should have been avoided. Yeah, so in this case, it brought the materials in, but it's not trying to map them. It's already aware that it does not need to map them specifically for the particular elements. So we hit OK. And then this is kind of like an important thing. It does give you error logs if something can't change or update. This is good whenever you're doing any sort of data management or quality control. It will tell you every single little thing, kind of like Revit, how Revit tells you every single little detail you do. It's kind of incorporated into Konstru, but it's good. It's good. It lets you know certain things. You can also export this and send it out if you need to share it with the team for any particular reason. But in this case, we can hover around our particular Revit model and try to get a look at what's going on. We notice that we have a big fat column because we updated it in ETABS and that got updated. Nothing got changed in the sense of geometry or something got wrecked. We just noticed that the particular column got updated and the beam got updated. So that is a very simple, very way of showing you how you can go from one application, Revit, to another application, ETABS, using Konstru, and then going back to the original source application. Kind of like how we talked about in the beginning, using all these roundabout workflows. Again, you can customize the workflows you like. These are just examples. Now, one thing I do want to show is, not the web yet, I guess we're still, is the idea of, oops, let me leave this here for now. We'll go back to this in a second. But is the idea of using a model that has been run on to run analysis on it and then see all those data and analysis update within Revit. So let me move this aside. If we can take this existing model, for example, we go ahead, if everything should be set up, I remember setting up before, let's find out. We can go ahead and create, or we're going to go ahead and run this. So let's make test. Okay. Should be specified, the load should be specified. So it should be able to run. Now there's a backup. Okay, now yeah, hold on. Huh? I'm gonna open up a different model first. Sample, yes. One moment. For the next example, what I'm trying to do is I'm going to try to show a model that you run an analysis on. And then using this model, you can take that analysis data and bring it back into Revit. I'll demonstrate that in a quick second. Okay. There you go. Okay. Give it a second, just loading out the application. And once it's up and loaded, we'll just run it. We should be good to go with analysis values. All right. Now that we have this all set up, we can go ahead and run analysis. Now, before I get this going, we're going to make 2 different containers. We're going to make a Konstru container dedicated to the ETABS model, a Konstru container dedicated to the Revit model, and then we're going to merge them and take that data and let Konstru do the merging and then ultimately bring it back into Revit. To start, we're going to go ahead and run this model. Take a little minute. There you go. It's running. It's doing all the things it needs to do. So let's give it a second. It's analyzing. Let's give it a nice second. And there you go. We have an analyzed model with sort of deflections and everything. We can take this now and upload it into Konstru. Before we do that, let's go ahead and make an entry container. If you're following along, go ahead and go to your dashboard in Konstru, and you can go ahead and create a new model. Let's call this the AEC Tech ETABS analytical run. There you go. Create a new model. And then we can take this Revit model here, and then let's go ahead and make another one for this, just for the time being. Oops, create a new container for this. I won't be surprised if you end up having like a million tabs open for all the times you make a Konstru model, but try to keep it at a minimum. So let's say Revit for merge. Create model. Now we have two empty containers that we're going to put data in. The AEC Tech ETABS analytical run, and then we have Revit for merge. We can go ahead and take this model here, tools, Konstru, sure. And we can go to where are we at? Yeah, ETABS analytical run. Now that's saying all the data, if I'm doing this correctly, all the data within the beams, such as the forces and all that, and the load cases, should have been sent in. We'll find out just now. We have the option to upload analysis results, which we're going to click on because we do want that. We do want particular load cases. Let's say we want this one. One caveat is you can only upload one load case at once, so keep that in mind when you're doing these kind of transitions and translations. And just emphasize the one you're particularly looking for. And once you're all satisfied, update Konstru. And then we'll be greeted with this very long list of elements, which you don't need to review all the time, but if you can, you can. We notice a couple of conditions. That's okay. You can go ahead and hit done. Plugin successfully completed. Great. We uploaded the model with metadata. If you want to take a look at it, we can go ahead and go to the empty container we created and just refresh it. You don't always have to make a new tab. Once you refresh it, you'll notice the elements are going to be there. If you click on a particular element, you should be greeted with some data. So if I go scroll on at the end, we're greeted here with some load force data, which wasn't there previously. Now we have to take this and now merge it with the model from Revit. Let's go ahead and upload our model from Revit into the new container. Now one thing I'm going to focus on is Revit for merge. This time we're going to want to upload analytical geometry specifically because we want to combine sort of the analytical data coming in from ETABS with Revit. So go ahead and adjust. Once it's done, we can go ahead and view the model or hit click done. Let's just go back to the tab we had open and refresh it. Revit for merge. This is the standard model we saw in Revit, and then now we have two models. They kind of pretty much look the same, but we're going to go ahead and merge the data between them. In this case, you can go ahead and go to AEC ETABS analytical run or the Revit for merge model. You can go ahead and you can view it by change and then compare to, one second, no, my bad. You go to the top end where it says visualize elements, and you have the option to repair, history, cloning, change, people. We covered this earlier, but in this case, we're just going to look at compare and merge. Compare and merge, you're going to pick another model. So the ETABS analytical run is going to be our compare and merge model. Give it a second. There you go. It's updating both models in the same spot. You'll notice they're being put in place and being trying to correlate. You have the option to transform the geometry if you need to. Like if you want to say, I don't know, there's a series of offsets happening and some models don't necessarily align, which can happen when you're dealing with design versus analytical models. It can happen. In this case, we're controlling everything pretty well, so we don't have to do any particular offsets. Go ahead and hit preview, so that way it resets. Once everything's good, that's right. Press next, and then it's going to give you a couple of options here. You're going to say things have been updated, things have been added, and things that have been unchanged, matched, and unchanged. In this case, we're looking specifically at the updated components, such as these elements here. And then we can click off to see certain things that are not being changed or added. In this case, we're just going to leave it like this. You also have the option to edit certain things when you're merging, such as adding new elements or update existing. In this case, let's not add anything new. Let's just focus on update existing models. And once that's all satisfied, we can hit merge. And it's going to ask you to confirm the merge operation, ultimately creating a brand new model. It's going to try to join the names together, but in this case, we can just say merge. Did it just change? Okay, sorry about that. We can just hit merge model. and then we'll be created a brand new model here that should contain all the data that we merged from the ETABS and Revit model. Now we can take this and just simply bring it back into Revit. So let's go view it by default, and then AEC Revit for merge. I believe so. Let me check one thing real quick. Perfect. And now we can go back into Revit. We can go ahead and now one thing I do want to note is that your beam layout should update with all this data, especially if it's on a particular beam. You should be able to start to see things showing up here. Right now there's nothing because I haven't updated it, but once we do this, we should be able to see everything. So go ahead and construe in what you need. If I've selected the right model, I believe it should be fine. And then we don't need this anymore. We can go ahead and download to Revit. Let's just update the model, and we should see a dialog with a lot of updates. Perfect. Let's get proceed. Now, assuming this upload goes correctly, our little tabs over here, such as LO1, LO2, should have been updated. The beam type should have been updated with whatever particular new beam sizes or parameters came in. Sometimes Konstru can take a second, and that's okay. You have to be patient with it, especially with larger models. You definitely have to be patient with it. But again, when you're transferring this much data between softwares, there's a lot of management happening in the back end. So it's normal to have to wait a little bit. Once it's all good, you hit done, and then we should be able to see these things should have been updated with any specific new changes if need be. If we click on a particular element, we should be able to see updates on the beam sizes. There you go. Not the beam sizes, I meant the forces. One thing I should note is that when you're transferring certain elements across, if they don't match exactly how they should match, like for example, this is empty here. If the parameter name doesn't match exactly the incoming data name, such as the M3 start, it won't know where to place it in Revit. That said, you can go ahead and specify that when you're doing the translations using filters, or also when you're translating from ETABS, and say M3 start has to be specifically a specific factored load. And that is one way of getting the data across and ensuring that all your beam tags, if a beam size change or whatnot, updated properly. And okay. And if we go back, one other thing I do want to demonstrate. So that sums up the idea of like how to go model merging, how to go from one application to the next, and how to put it all together. Lastly, what I'm going to show is like an example of how to use the web interface in a little bit simpler way. But we're going back to Rhino for a second. The very last example file is going to say something along the lines of Konstru web example JH panels with custom attributes. This is just a very simple file that takes a curly surface, or wavy surface, I should say, and then translates it into a series of panels. In other words, adaptive components for Revit. So that way you can make them a little bit more parametric, and you can go ahead and update that. Now, the reason why we're showing you this is particularly for the attributes function. Sometimes you want to showcase something using the Konstru model that's not just like structural data. You want to show some particular attributes. So to demonstrate this, I'm going to make another empty container just for this particular example. AEC Tech, let's call this the surface example, surface attributes. Create model. We can go back into Rhino. We select the component, or we select the model we're looking for. Hit OK. Should be all good. Now down here is what I'm trying to say. We've added a series of attributes to each individual little square, such as area and elevation. Now, once that is properly set up, we can go ahead and place that into the attributes input of when you're creating an adaptive component. And once you've created the adaptive component elements, you'll see a series of elements that can be sent over into the Konstru. Let's go ahead and send that over. Looks good. View model. pretty simple, pretty straightforward, right? But if you click on a particular element, you'll be shown a series of other conditions here, such as area and elevation, which is a little different from before. So if we view profile, if you go view by and go down to where it says attribute, you'll be seeing custom attribute names. In this case, whatever you preloaded into the file will show up automatically, such as area. It'll automatically get colored based on area. Of course, you have the option to change the colors if you want to pretty much most options that you want. What's useful about this is that, let's say you're building a certain model and it's not necessarily meant to be shared across applications, if you want to do that. It might be meant to be shared in the team to sort of share 3D data and visualize certain information, such as, in this case, the area of a specific element. So let's say you're looking at a facade and you're looking at glazing panels in their areas, or maybe you want to look at the elevation of certain things. You can do this for any element. It can be for the beams themselves, it can be for floors, it can be for adaptive components such as this, like if this was some crazy curly surface that was sitting on the facade or on the roof, or any condition. Point is, Konstru also has the potential of being a sort of platform for also showcasing models similar to the original two models I was sharing earlier, which such as the tower, if you want to showcase that to a client, or well, okay, what I want to show is the other two example models that we're going to talk about in a second, such as yeah, here we go, such as Cornell Tech. Again, like this is just an example model of, like, let's say you're working on a project and you want to show it to your team or to a client and then show certain attributes on it. You have the option to use this as a visualizer. You can minimize the window and have this become an existing 3D view, where you can show this on your phone, you can show this on a tablet, because again, it's running on the cloud, it's running on the web. So it doesn't have to rely on any specific hardware conditions. Same thing for another example model, the W57 building by Big. Again, you can show this and use it as a showcasing device to show not only 3D models, but also show important data that can be used for discussions and team meetings and so forth, and not have to rely on software or hard to read series of Excel sheets. And lastly, we covered, well, we indirectly covered this a little earlier than expected, merging some force data from structural analysis to Revit, kind of put that into here. But essentially, that's a little bit of workflows, how to use Konstru across different platforms, and how to get through certain metadata and manage models and so forth. Are there any particular questions or comments or feedback? If there are, feel free to put them on the chat. We have various people here ready to answer them, as well as myself. Also, you can put them on the Slack channel. We will, if we can't answer them right now, we will definitely answer them later. Feel free to even speak up now if you have anything to say. Otherwise, we'll give it, like, say 10-ish minutes to just kind of sit, and if anyone has something to say, go ahead. While we're waiting for questions, I do want to show this one more capability of Konstru being able to be clip-through model. So when you're dealing with the web interface, you have the ability to create section planes and be able to just transfer through the model and be able to see different aspects of it and not just the holistic thing. It also has the option to create what's called a clipping box. So not just do a slice of the overall building, but you can also do a particular box of something you want to zoom in on. So you have the options to create the clipping box and specify its length, its width, its height, and zoom in on that particular portion of the project. You can also crop by levels, as shown in the diagram here. So these are often also little other tools available with Konstru that lets you interface with the project and present it in a little bit of a clearer format if need be, for whatever reason. And let me see, is that Is there anything on the Slack channel? No questions on the chat or anything else? There we go. Can you wait? Yes. Can you we have a question that says, can new columns be added in Excel to create new parameters in Revit? You can technically add geometry to Excel as long as you know you can define its endpoints. But then if you, well, that's a geometrical addition. But then if you want to create new parameters, you also have to specify that in the Excel sheet as you're creating the column itself. Let's say one more thing. Yeah. Konstru, well, where's the, also regarding to the last question about the creating columns in Excel and creating new parameters in Revit, Konstru will automatically create parameters that aren't already present in Revit. So as you create data, it should be able to read it back and automatically adjust to it. While we're waiting for any other particular questions, there's one more thing I'd like to show. In the meantime, we have a little video that showcases also how you can use Konstru models and to interface with other core apps. For those of you who have been to other workshops that we're providing, one second. For those of you who have been other workshops we have been providing, we have the option of being able to create Konstru models and use that Konstru data to interface with other particular core apps, such as the Mirar application we have, where you can take all the built-in Konstru data that you've built using the Konstru models and components, and you can go ahead and assign that to whatever you need to, and use that as another way of interfacing and showing data. Now, also, one thing you can do is once you made a Mirar app, you can use all that Konstru data you created and ultimately create a thread report from the Konstru data. It's all very possible. It's all very much like a series of different bridges you can collect all and put them all together. And I know the video is going very fast, but the intention is just kind of show a preview of it. This is something that can be shown in a different workshop we do provide. So there's a workshop called Core Apps where you can combine all these things, but also the idea is how you can take Konstru models themselves and go ahead and combine them all together. And use all the core apps that we have and have them be used for your project benefit and showcase different possibilities, different things, and how you can combine them to improve your workflow, if not make your presentation even better or your workflow even more sophisticated. And for those of you who aren't aware of what the core apps are, Mirar is a viewing platform primarily with metadata attached to it, similar to Konstru. And then Thread, the last thing you saw with the report, is a sort of documentation platform. You can show graphs, data, you can show numbers and all sorts of other possible metadata you want to extrapolate into really just numbers. Kind of shown as shown here. I'll give it a couple more minutes. I'll give it till 11:50. If there's any particular questions or comments, feel free to post them, or feel free to just speak up. And if you haven't already filled out the survey, please fill out the survey for AIA credit. We are providing AIA credit for every single workshop you participate in, including this one. So if you haven't done so, go ahead and get your credits by filling out the survey. It's been posted on the chat, and it should also be posted on the Slack channel. So whichever one you have access to, feel free to click on the link and go ahead and fill it out for your benefits. Okay. Well, if there's no more further questions or comments or any feedback, I guess we can call it and just leave it as it is. Thank you for coming and attending the AEC Tech workshop focused on Konstru.